In this video, we are going to see the topic integration by parts. In the last video, we have discussed about the integration by parts tabular methods. So in which the algebraic expression is given, we can apply the tabular method. Now we will take first of all the formula. So the formula is given by integration of u dv. Integral of u dv equal uv minus integral v du. So this is the formula for the integration by parts. Now let us go with the first example. First question: evaluate or evaluate integral len x dx. Len x dx. So as we know the u, so you have to take the u in such a way that the u must be in this order: light, L-I-A-T-E. So what is the meaning of this one? So here the L means the log function, logarithmic function. You have to give the first preference, you have to take the u. Next one, it is the inverse trigonometry function. Any inverse trigonometry function, you have to take it u. The next one here, the algebraic expression, that is the polynomial, you will have x square plus 6x or 2x plus 5, like that. Now the next one, we have a t, it is the sine function, trigonometry, sine, cosine, tan. And the last one, it is the exponential function. So this is the order you have to go with the taking u. The first preference you have to give it for the len. So you have to go from here to here. This is the order you have to follow. Now here the first problem. So directly many of the student will directly say the integration of len x is equal 1 over x. No. So therefore we have a formula: integration of 1 over x is len x. But I don't know the formula for integral of len x. So this cannot be calculated direct method. So direct method is not possible. Now we have to go through the substitution method. The substitution method, if you take the len, the du must be present in the integral, but du is not there. 1 over x is not there. Suppose if you have like this, 1 over x dx, it can be solved using the u substitution method. By taking u equal len x, you will find it what? This is my entire thing is my du, right? But here 1 over x is not there in the integral. So I cannot solve this problem using the substitution method. There is a only way, we have to go through the integration by parts. So first thing you have to check, is it direct? First, is it possible to do it in the direct? If it is not possible, substitution method. If it is not possible, then by parts, integration by parts. So this is the order you have to go through for any evaluation of the integral. Now let us go with this one. What is u here? The u is nothing but len x, and this is dv. U equal len x and dv equal dx. So I will differentiate here. What is du, which is equal 1 over x dx. So I need here v. So how will you get v? If you integrate both sides, you will get what? V equal x. So I write it the formula. The formula I, this is a given integral I, is equals uv minus integral v du. So just I substitute the values. What are the values we will have? Just substitute here. So here we will have uv, u and v. So it is x len x minus integral v, which is equal x, and du, which is equal 1 over x dx. So now you can easily integrate this integral. So here x with the x cancel, so you will get integral of dx, which is equal x minus x plus c. So this is the integration of len x, that is x len x minus x plus c. Since it is an indefinite integral, we are not writing here c, so we are writing at the last the integration constant. Now we will take one more example here. Yes. The next one I will take integral x len x dx. Yes. How will you solve? So as we know, you have to take the u method. The u value you have to take. The direct method is not possible. Here the substitution method is not possible. Then you have to solve by using integration by parts. Now we will take the u value. Here there is a two functions are there. One is logarithmic, another one is a algebraic expression. Therefore, I will rewrite this one. I can rewrite this integral as len x dx. Is it same? So just I will swap in the correct form. Now we can take this one as a u because you have to give the len as a first preference for taking u value. Now I will take len x is u and dv is equal x dx. And here if you differentiate, you will get what? Du equal 1 over x dx. And here if you integrate both sides, what happened? So therefore it is v equal x square over 2. Now I write it the formula. The given integral is equals to the integration formula, integration by parts, that is uv minus integral v du. Just I will substitute all the values here. So what happened here? u and v. So it is, I will write it x square over 2 first, but then len x minus integral v. It is x square over 2. The du is nothing but 1 over x into dx. So you can simplify this one. What is the simplification? Here x with the x cancel. What are the remaining things? So here you will have x square over 2 len x minus 1 over 2 is a constant like a c. I will take it outside the integral. The remaining things in the integral is only x dx. Now you can easily integrate this one. What is the integration of len x dx? Which is equal x square over 2 len x minus 1 over 2. The integration is here. So it is x to the power 2 over 2 plus c. The final answer you have to multiply. So the answer will be x square over 2 len x minus x square over 4 plus c. So this is the final answer. Now you can ask why we are not writing this one as a tabular method since we have a polynomial here. Yes, we can, but we have to know the logarithmic integration of log x. So if you go with the tabular method, this one u equal x and this is dv, here len x. So here continuously you have to differentiate, here 1 and 0. But what is the integration of len x? That is difficult to remember. That's why we are applying this problem in integration by parts method, not as a tabular method. Clear? We can solve, but it is very difficult to know. Just now we have evaluate the integral of len x. We will have to remember this formula. So it is very difficult. That's why we are avoiding this one. So we will solve using the integration by parts. The next one, we will take one more example. So I will take one more example, which is integral root x len x dx. So root x len x dx. So here also the same story we have to repeat. So I have to take it as the direct method not possible, u substitution not possible, and the integration by parts we have to solve this problem. So that I have to rearrange this integral as len x square root of x into dx. Now what is your u? U is nothing but your len x and this is my dv. U equal len x and dv equal, so x root x I can write it as x to the power half into dx. When you integrate both sides, what happened here? So it become x to the power 3 over 2 over 3 over 2. So I will not write it this one. First you have to simplify. So therefore you will get 2 over 3 x to the power 3 over 2. And here you will have du is equals 1 over x into dx. So I write it the formula here. This is the I given integral is equals to uv minus integral v du. So therefore, I just substitute the values here. So u, what is u? Len x. What is v? 2 over 3 x to the power 3 over 2. So this is the first part is finished. This one. Next, minus integral v. The v value is 2 over 3 is a constant. I will take it outside. X to the power 3 over 2. Now what about the du? The du is nothing but this one. 1 over x into dx. How will you simplify this one? So first of all, you have to simplify this one before integrating. So how will you simplify x to the power 3 over 2? If you bring x power 1 up, you will have minus 1. Therefore, the answer will be x to the power half. So I write it this one as it is 2 over 3. The constant term first, I write it 2 over 3 x to the power 3 over 2 len x minus 2 over 3 integration of x to the power half dx. Now when you integrate this one, 2 over 3 x to the power 3 over 2 into len x minus 2 over 3. So the integration is x to the power 3 over 2 over 3 over 2 plus integration constant c. And at the final step, you have to simplify this one, the fraction 2 over 3 x to the power 3 over 2. It is len x minus this multiply with the numerator. We'll have a 4 over 3 into 3, which is 9. X to the power 3 over 2 plus c. So this is the simplified answer. If you remember this problem, you can solve all the different types of problem like this. So these are the same problems you will find it. Integral len x over root x. So you have to make it to the numerator. Therefore, it can be rewritten as x to the power minus half len x dx. This is the same rule we have to apply again. And next we will have integral of root x into len root x. This is also same rule. So here, as per the property of len, how will you write this one? This is len x to the power half. So I can write it as 1 over 2 len x. Since 1 over 2 is a constant, I will take it outside. Therefore, this integral becomes integral x. Here we will have 1 over 2 outside. This is len x dx. This is actually the same thing, but outside multiply with 1 over 2. Is it same thing? Same problem, but outside 1 over 2 is due to this root as per the property of len. So these are the similar problem you can solve as a exercise problem homework. Now the last problem we will discuss in the integration by parts, it is integral sine x len of cosine x into dx. So far we have discussed about only the logarithmic or exponential, that is logarithmic and the algebraic form. But here you will have a logarithmic function as well as the trigonometry function. So we will discuss here how to take the u and v. So as per we know, you have to give the first preference for only for len. So therefore I rewrite this integral as len of cosine x into sine x into dx. Therefore, here we will have, I will take this part as a u and this one as a dv. So you will find it u equal len of cosine x and dv equal sine x dx. So when you differentiate, du is equal 1 over cosine or the chain rule. Here it is a chain rule. Len differentiation is finished. Now when you differentiate the cosine, it becomes minus sine. This is the differentiation we are doing here. Now into dx. So I write it this one as what? It is minus sine over cosine into dx. You can write it as tan x as well. Now here I need the v value, so integrate both sides. We will have v equal integration of sine is minus cosine x. We will not add it here plus c. At the last we will add. So the given integral I is given by the formula uv minus integral v du. When you substitute this one, the u and v, so you will find it minus cosine x len of cosine x minus integral. Here we will have cosine v. What is the v value? Minus cosine. What is the dv value? Du value? It is minus sine x over cosine x into dx. So what are the simplification you can do it? Cosine with the cosine cancel. This minus and this minus, it become plus. Now the given, the remaining inside the integral is, what are the remaining function? Cosine x len of cosine x minus, it become minus of minus plus, the remaining thing is only inside the integral is sine x dx. When you integrate this one, what happened? Minus cosine x len cosine x minus the integration is, what is the integration? Minus, which is become plus cosine x plus c, because the integration of sine is minus cosine, minus of minus, it become plus the integration constant c at the last, since it is a indefinite integral. So in this video we will complete the class. So what are the things we have discussed about in this video? We will discuss the integration by parts using the formula, not in the table method. The table method you have to solve only if you have a exponent, that is the algebraic expression. It becomes zero after differentiation. Then only you can apply the tabular method. Thank you.